Hey guys, this is Sanjay from FTC Team 7477, Super 7. Today, I'm going to be talking about Radix sort and how you can use it to sort different types of arrays. Let's start with the actual Radix sort method, right? So, we initialize it as, wait one second. So, we initialize it as public static void because we don't want it to return anything. And we want the elements to be used throughout the whole main class, which is over here. Similar to heap sort, this sorting algorithm has two different methods other than the main method. So it might be a bit harder to understand code, but I'll give an explanation of every single line. Right. So let's talk about the first method now, shall we? So this is the radix sort method. Radix sort works by sorting the input array one digit at a time, starting from the least significant digit to the most significant digit. It uses counting sort, which is a different type of sorting algorithm, as a subroutine to sort elements based on each digit. So let's talk about radix sort first, right? So this line, int max equals arrays.stream of array dot max dot get as int. So first we find the maximum value in the input array using arrays.stream of array dot max dot get as int. We need this to determine how many digits the largest number has, which will guide how many times we need to process this array. Next, let's talk about the for loop. So for int xp for exponent equals 1, max, which is this over here, over xp is greater than 0 because we don't want it to be negative, and xp times equals 10, so it increments by 10 times each time. So now we enter the for loop, which processes each digit starting from the least significant digit, which is the ones place. The variable xp stands for the current place value we're sorting, which could be like ones, tens, hundreds, or anything of that order. We start with xp equals 1 and keep multiplying xp by 10 until we've processed all the digits of the maximum value. So now let's talk about this part. So at each iteration, we call the counting sort method to sort the array based on the current digit, which is represented by xp. In this method, we use a variant of counting sort to sort elements according to the specific digit being processed. So now let's code the counting sort by digit. Let's sort the counting sort method. So this one takes two parameters, the array and the exponent. Sorry. For Oh wait, okay, I typed that in wrong. It should be count brackets and in parentheses array of I. So the counting sort method involves lots of like nested arrays in like expressions. So just be aware of that. Like if you're forgetting parentheses or brackets, just like keep that in mind. Oh, alright. Alright, so this should be our finished counting sort method. It's pretty extensive, so I'll like walk you through it. So, in the counting sort method, we initialize two arrays. First, the output array, which will store the sort array for the current digit. Secondly, the count array, which will store the frequency of each digit from 0 to 9. We start by counting how many times each digit appears in the array. This is done with this line. Count of so we count array oh yeah, basically we take the indice of array of I over exponent mod 10 and we increment that. So this extracts the digit at the current place value. Next, let's talk about this for loop, right? So for int I equals 1, I is less than 10, I plus plus, and this line over here. Next, we modify the count array so that each element at index I contains the total count of numbers less than or equal to I. This allows us to determine the correct position for each element in the output array. This step is crucial for the sorting process. Next, let's look at this for loop. For int I equals array.length minus 1, I is greater than or equal to 0, and I increments by -1 each time. So, now we iterate through the original array in reverse order. This reverse iteration ensures that we maintain the relative order of elements with the same digit value, which is important for sorting purposes. We place each element in its correct position in the output array based on the data in the count array. Now let's talk about this line. System.array copy output 0 array 0 array.length. So once our output array is built, we copy the contents back into the original array. So this ensures that our original array is correctly sorted. Now let's see this in action. Let's have some random digits. Alright, so we have this array, and now we call radix sort. So radix sort of array. Now we can print it out each time using the standard for loop. Use IntelliJ's built-in command for printing out, and now we can do print array of I, right? So let's run this code and see what we get. We get our fully sorted array using the counting sort method and the radix sort method. Now let's do like a quick recap of it. Actually, first we can visualize how radix sort works. So we begin by sorting the array based on the least significant digit, which is the ones place. So then we repeat the sorting process for the tens, hundreds, and higher place values until we've processed all the digits. So at the end of this process, the array should be fully sorted. So, to summarize, radix sort is a non-comparative sorting algorithm that efficiently sorts integers by processing individual digits. It works well when the input values are relatively small or when the number of digits is limited. Radix sort has a time complexity of O of 10 times k, which I'll write O of n times k. So I'll write this down here, O of n times k, where n is the number of elements and k is the number of digits in the largest number. So we can try calculating the time complexity for this array. So the amount of elements, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9, right? So let's say complexity, should be in comments. So time complexity of this array, when radix sort is performed on it, right? That's just O of 9, and the largest number is 2, 3, 4, 5, which has 4 digits. So we have 9 times 4, which is 36. So the time complexity of radix sort on this array is O of 36, but it can vary. So this makes radix sort particularly efficient for certain types of problems. Thank you guys for watching this Super 7 programming tutorial, and make sure to be updated for future programming tutorials by Super 7.